Okay, so what we're going to talk about now is writing a linear equation. Writing the full thing if given a table. And actually we got two things to solve for here in the table. We've already discussed, I've already done a video over how to find slope. M stands for the slope. Now, what we've got is this equation, this form right here, this formula, y equals mx plus b. That's called slope-intercept form. And the m stands for the slope of the line. And we're going to solve for m, which is just rise over run, which is the delta y over delta x. And what b stands for is something different. This is called the y-intercept. You can also think of it as an initial value, but it's the y-intercept of a line. Now, an initial value, a line goes forever, so it doesn't really have a starting point, a true line, but we usually like to say that things start at 0. What this is, it's the value of y when x is 0. It's where it crosses the y-axis. That's what b stands for. So the value on the y-axis where the line would cross it. And that's always going to be where x equals 0. It's the output when the input is 0. So we can find b on the graph, or I'm sorry, on the table by looking at the x values and looking at where the x is 0, whatever y is, that's going to be b. Okay, so if you're given a table of values and you have verified that the table represents a linear relationship where there is a constant rate of change, okay, so at some point we'll talk about that. But you can find both the slope and the y-intercept in the table and write the equation of that line. To find the slope, we're going to use delta y equals delta, or m slope is equal to delta y over delta x. To find the y-intercept, we're going to find the coordinate xy in which the x-coordinate is 0. So the b, the y-intercept, is going to be some coordinate here. So let's find these things. Okay, little review for slope. We got to find our delta x. I'm just going to do one of them right here. To go from a -2 to 0, I had to add 2. To go from a -4 to a 2, I had to add 6. So what I'm going to say my slope is, this is the delta y right over here on this side. This is delta y. And this is delta x. Slope is delta y over delta x. So I've got a positive 6 over a positive 2, which that just equals 3. Okay, my y-intercept, to find that, if my table has a value of x that's 0, in this case it does, it has it right here. This right here is my y-intercept. This shows me where the y-intercept is, where x is 0, y is 2, so my y-intercept is 2. So my y-intercept is the number 2. Now I just write that equation, y equals mx plus b. This right here is my m, and this right here is my b. And I'm going to write the equation y equals mx plus b. But I'm going to replace the m with slope, which is 3. So I'm going to write y equals mx. Well, m is a 3, so 3x. And then my y-intercept is 2, and it's positive, so plus 2. The equation of the line, which goes through all of these points, is y equals 3x plus 2. Let's look at another. Let's determine the slope. I'm going to go right here. To go from 0 to 1, that's an increase of 1, plus 1. So my delta x right here is going to be 1. My delta y looks like I'm decreasing. I had to subtract 10 from 50 or I'm sorry, 10 from 60 to get to 50. So that's going to be minus 10. So my slope is going to be delta y over delta x. This is my delta y. My delta y is negative 10. So I've got negative 10 over 1, and that just simply simplifies down to negative 10. My y-intercept, I find that right here. I look to where x is 0, and I look at the y-coordinate where x equals 0, and it is 60. So my y-intercept is at the positive 60. Okay, this is m, and this is b. So I'm going to write my equation in the form y equals mx plus b, where m is a negative 10 and b is a 60. So I've got the equation y equals a negative 10x plus 60. That's the equation of the line which goes through all those points. Okay. This one's a little bit more, we've got decimals in here. But you know what? It doesn't really matter. It doesn't matter. What I'm going to do is I'm just going to kind of ignore the decimals. And I'm going to show you that we don't even have to go to the next point that's in our table. We can look for numbers that we actually maybe prefer to do. Okay? Like I can go my delta x, I could go from here, from this point where x is 0, all the way to where x is 2. And that's an adding 2. Then I have to go on this side to get my delta y, and I'd have to go through those same, the same corresponding y coordinates that correspond with these x coordinates. And that goes from 0 to negative 1. So that's down 1. Okay, this side on the left, this is delta x. This side on the right is delta y. Slope, once again, is delta y over delta x. The delta didn't look so hot. Looked like an x. Still kind of looks like an x. I'm not sure. I'm not writing very well. Okay, delta y is a negative 1. Delta x is a 2. Okay, negative half. Can we simplify that? And you might think, well, we can make that a decimal. Not so much. I actually prefer slope to be in terms of a fraction. That's fine. So my slope, or m, is negative half. Now my y-intercept is right here. I look at to where x is 0. I get that y is also 0 right there. So x is 0, y is 0. So my y-intercept, b, is 0. So I can write the equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. So I can write y equals m is a negative half, x, now here's the thing, plus b is 0, so I've got y equals a negative half x plus 0. The thing about it is, I'm going to make that negative half look a little bit better. Need to write that 2 a little bit better than that. There we go. Negative half x plus 0. If I'm adding 0, I don't really have to show that because adding 0 doesn't change anything. So I'm just left with the equation y equals a negative half of x. And that's all there is to graphing from or getting the linear equation if given a table Now, sometimes you might not have the point where x is 0, and then you have to calculate for it. But for right now, let's just get used to this right here. Let's learn to crawl before we learn to walk. And after we're walking, then we'll learn how to run. We'll do some of the harder stuff. That's all I have for now. Thank you.